Back with this 63 non-reverb Deluxe, and you can see here I mostly was able to straighten out this area of the front panel and get that jack that was at a weird angle more or less flush. It's still not perfect, but once damage has been done like that, unless you were to take everything out of this and take this to a machine shop, and they'd have to come up with a rig that could replicate this angle here without affecting this flange here. You know, it's a lot. So this is more than good enough. It's not really noticeable from most angles. You can see it if you know what to look for, but well, it looks better mechanically. It's solid. This is a good place to go forward. So we shall go forward. We will be starting with a recap. And given the popularity of the last couple of long format, almost real-time videos, I thought I'd do another one for you. We're going to recap this original 63 in almost real time, at least. Occasionally I might pause to go get a cup of coffee or whatever, you know. But we're going to get started on this. Now, with some of the other amps I've already shown how to do this on. In fact, the last one was a real-time recap. Those were previously changed out capacitors, and there's some tricks when dealing with the original filter caps like these and how the ground wires were done, and just some stuff about filtering in general that I don't think we've talked about, so I thought I'd talk about it. We're going to start by disconnecting this end of these caps. Actually, we're going to start by disconnecting the wires. It'll be easier to deal with the caps once it's out of the amp. Trying to do this without, I've got a USB cable going to the camera because this is going to be a long video, and I don't want to eat up my battery life. So just going to do this in sequence because they kind of overlap each other. So I'm adding a little bit of fresh solder to the old solder. Just introduces some flux. Makes the old stuff flow. You can also use a flux pen or brush on some flux, but that usually adds more than you need, and you end up with messes that you have to then clean up. So just adding a little bit of fresh solder usually adds just the right amount of flux to do what you want without making a big mess in the process. In the process, for my Canadian friends, in the process, people ask about what solder I use. Typically, I use Kester 6040 leaded solder. I have tried the 6337 and did not like its doming behavior on eyelets. It's really nice, though, when doing PCB boards. If I were doing a lot more PCB boards like I used to when I built pedals, I would probably switch to that. And there's some silver carrying solders which are very nice. But again, I find they don't offer any real benefit in an amplifier. And they are more expensive. And since you tend to use more solder on eyelets and turrets on these old amps than you do on a PCB, I don't find it cost effective. I go through a lot of solder. The 1 pound roll that probably lasts most guitarists and hobbyists many years lasts me about a month. I buy a lot of solder. And where did I put the tool that I literally just had in my hand? There it is. All the stuff I use, the iron I use, the kind of solder I use, a lot of tools that I use are all listed in the descriptions of the videos. They have been for the last, year and a half. So if you want information on that, go for it. I tend to use this 0.032 diameter as opposed to the 0.064 because I can control the flow of solder better. And if I need a lot more at once, like if I'm doing like a chassis ground connection, I'll take 2 strands of it and twist them together to make the thicker. Up to a few years ago, I stocked each and used each, depending on the job. But the price of solder has gone up so much in the last 2-3 years, like the cost of almost everything, that I just haven't. Everything has gone up. And so a lot of the stuff that I used to keep in stock at all times just to have, I now order either as needed or in smaller quantities. Oh, that ground wire does not want to come up. Why is that? It is really wrapped underneath there. So rather than just tugging and tugging and tugging and potentially breaking the wire, I'm going to go ahead and remove these two screws. That'll buy me the slack that I need. And the other screw is right here by the ground that I'm trying to disconnect. And that is probably why it is so tight. It's probably got mechanical clamp, it's mechanically clamped between the boards. Now that the boards are loose, that should come up much more easily. If I were doing this in a traditional way, moving the camera around, you'd probably get some things better shots of some things like that. But I'm going to do this more or less real time, which means that you won't see quite everything. That one's really tricky to access. Hold up this way. You can see right there. So, see if I can get this with. All right. Back to the dental pick. That one's really tight. Usually those ground wires are not that tight. They usually have a little bit more slack. This is one of the first of the new style Fenders ever made in '63. The big change in late '63. And this is one of the first, so maybe they were trying to set a new standard for how things were done. But those two grounds were much more exact in their length than I'm used to on most of these. All right, at this point, I like to clean the old board, and I use some isopropyl. And I don't remember which of you kind commenters suggested that the proper thing, because I was having problems with this leaking out, the alcohol leaking out of the gap. It's called a wash bottle, and this is a very nice one, about $12, designed for isopropanol, which is the same thing as isopropyl. And this is CHWB 1030, and it's fantastic, but it's about twice as big as I want, so I'm going to find a smaller version of this. Does this say how many ounces this is? No, it's a lot. It's a bit more than I need, but does the job without drips, does the job without spilling, so the added size and weight is a minor annoyance, and I will find a smaller version of it next time I go looking for such things. But it's called a wash bottle. If you search bottle for alcohol or bottle alcohol in any combination, you get all kinds of really interesting results that probably more people are interested in, but they don't necessarily promote good work on the bench with soldering irons. Let me move this out of the way and we'll get to this. Don't you hate when you're trying to work on a '63 Fender Deluxe and you turn to put it down somewhere and there's a whole bunch of Telecasters in the way? Life's hard. All right, as shown before, I like to put some paper towels down because hot things will be happening on both sides of this board as I go. And while this is a replaceable cutting mat, I don't necessarily want to replace it every week or two. So that helps. Let's make sure we're still in focus, still where we want to be. Can you see everything? That's pretty good. Let me back up a little bit. And how's the color? That should be good. And we'll get a sip of coffee. And put these screws to the side so I don't lose them. Those are going to be going back in pretty quickly. If they're going to stay out of the amp for a while, I either put things in stainless steel bowls, or I put things in little Ziploc sandwich bags and stick them in the back of the cab. So I'm going to remove all these, but what I wanted to show you on these original ones is that these wires here connecting the grounds, those are actually the negative leads of these caps. And so you don't necessarily want to just, if you were to just tug and tug and tug from this other side, you're not going to get anywhere because it's connected through there. I often will reuse these. Sometimes they're corroded. These look okay, so I'll reuse them. But sometimes I'll repopulate these with a new 20 gauge bus wire. But in this case, I want to reuse them. And I'm looking at this, and it looks like this one goes here, and this one goes here, and then this one will come out. Let's test that. Yeah, and this one will come out. And then on the positive side, all four will come out because you don't have any of those connections down there. I need to remember to look at what the camera is seeing from time to time to make sure I'm not doing a, hey, look at that, isn't that cool kind of thing to you. Those are just tucked in place, which is not perfect. Most Fenders had them tucked in and then bent under, not just tucked in the solder in the eyelet. So this is not as good as I thought it might be based on how those grounds were done. I think those ground wires might have just been cut a little bit shorter than someone anticipated on the line, and they just got away with it. But usually it's good to have just the tiniest bit of slack so there's no pressure, tugging at the joint. In this case, though, I don't want to lose these wires, and I do want to make sure that this one doesn't come loose. So I'm going to go ahead and remove the solder from this one. And as shown before, I just heat it up and then tap it. Gets most of the excess out. What's left, I will either use a solder sucker or a bit of braid or both. All right, now I can see that wire is there, but it's coming up and then going to the right, and that's mechanically not great. So I want to do is get in here and heat it up and free it from the side where it is, held on by solder, but it's not a mechanical connection. So I bent that up, and I'm going to use a bit of braid. Get a little bit of the old excess solder off there. I know this is fastidious, ticky-tacky stuff, but it's worth it. You'll see why. That side looks good except for the old flux. Now that that's not, solder stand is trying to fall off the desk. That's great. There you go. All right. And now that is free in the joint and standing up, I can take that and bend it over. See how it's right there? It's got a little bit of solder holding it there. That's why it's fighting me. If I were just to say, hey, here's the before, and then do some magic and make all these mistakes off camera, then show you the after, you wouldn't see those little things that sometimes sneak up on all of us. What I want to do is get that to go in more and go to the side. Can you see that? And then bend it back this way on itself. It's a bit hard to get started because there's no slack. There we go. Now, can you see that? Let's see. Come on, focus. There it is. Now you can just see that it's crimped on itself before solder. So if it's tugged that way, it can't go anywhere. It's on there tight before I even solder, then it went on. Now what I'll do on these negatives is I'm gonna cut them. I know it's anathema to crazy collectors. I'm going to use the little excess bit there on each of those wires to do much the same thing. You can see all that old flux sizzling. Or you would if I put the focus back, wouldn't you? Yeah, if everyone's like, hey, I love the long format real-time things, occasionally I will make a focus mistake like that as I try to alternate so you can see bits. And these joints that already have two wires in them, it's hard to knock out all the solder, so that's where the braid and the suckers help. Now I can see that this wire is coming like this, and then this wire, which is coming there, is also going like that. This is the one I'm most concerned about because it has the least amount of slack. All right, now they're all mechanically good. We get some of that old excess solder there. All right, that's good. And I can trim off that excess just a hair. Throw away these little bits. And I'm going to knock off these other blobs of old solder, but I'm going to do it in my trash can rather than here. Just trust me. You just heat it up and then you knock it till all the stuff goes out. Be careful doing it. Don't do it in shorts. Don't get it in your eye. You will have molten metal. It's not fun. I just tap it into the trash can and away it goes. All right, next I'm going to take out these two resistors. It's a 10K and a 27K. And a Deluxe reverb would be 10K, 10K, and the non-reverb Deluxe is 10K, 27K. And I don't like and I don't trust 1-watt carbon comps in the power supply of Fenders. They fail too much. These still measure okay. They're still okay now. If a future owner of this amp wants to put them back, I'm not damaging them, and they will be returned with the amp in a Ziploc bag, as mentioned. So when I work on these amps, there are things which go in the stainless steel bowls or a bag temporarily, and there are parts that I remove that go to a different bag to be returned with the amp, just in case someone wants to say, hey, a 10K 1-watt carbon comp is magic. That will transform how the entire circuit behaves. No, the circuit will behave the same. It just won't be as reliable for the higher voltage stuff. All right, so that's all looking good. And as I've shown in previous videos like this, I like to then go back here. And I'm not using any force. I'm not scraping the board. Just this flat, hardened screwdriver bit breaks up that old dried flux very nicely. So instead of it being kind of crystallized on the board, it breaks up into a little powder that washes off. Because if I just apply the isopropyl without breaking up into dust first, it makes gummy spots that are harder to clean. So this does a lot of the work for us. And the reason I do this is not only is flux ugly, but that old flux, it's older than I am. It's trapped in dirt and stuff over the years. And dirt within a solder joint is not our friend. And it was not there originally. So why not go ahead and take care of it now? What I'm doing is trying to make the power section of this amp pretty much essentially, look at all that yuck, pretty much essentially 1963 again. People are like, oh, I want it to sound like a 60-year-old amp. That's where the mojo is, so I can sound like all my favorite artists. You know, your favorite artists from the 60s and 70s were using new or 10-year-old amps, not 60-year-old amps where everything's gone out the window as far as what Leo or Jim Marshall or Dick Jennings or anyone intended. Trust me, if Jimmy Page and Eric Clapton and Jimi Hendrix and the Beatles and all the guys from the Wrecking Crew sounded okay through a pretty much brand new amp back in the day, so could you. I don't think any one of those guys said, wait. I can't find my tone until this thing's at least another decade old. Hendrix was getting new amps all the time. He'd break them, wear them out, catch them on fire, send me new ones. If he hadn't died in 1970, God rest him, he probably have went through a period of playing a whole bunch of Silverface, ultralinear Fenders, 150, 180 watt monstrosities, and now none of us could afford them. God help us if he used a Klon into one. I'm not making fun of Jimi Hendrix. I love Jimi Hendrix. And I'm not making fun of Bill, can't remember his last name, who made the Klon. Nice little pedal. The world's just a crazy place. All right. So, fresh paper towel. Get any remaining flux. And then, as I've shown a few dozen times on the channel, at least at this point, there's still a lot of isopropyl in this board. So I just heat up the eyelets and it drives it away and out of the fibers. And any water from the atmosphere that might be in this board as well gets displaced by the isopropyl and also driven out. So you end up with a more reliable connection because everything's insulated from each other. This eyelet's not connected to that eyelet by any means other than what you choose within the circuit. It's more of an issue with the preamp stuff, but on rare occasions I found leakage, which had bad results in the filter cap board. If you have recoupled caps, if your decoupled stages recouple through a bit of cardboard at random amounts, it's not usually a tonal recipe that anyone's seeking after. All right, we're going to pause right here, and I'm going to get all my ducks in a row for the stuff that goes back on this board, and we're going to talk about caps and how they work to a degree and why we choose what we choose. We'll get some more coffee first. All right, I got some goodies here. Let me show you one thing I do sometimes. It's not really necessary here for just two resistors, actually over here for two resistors, but it can be useful when doing stuff on a board where you're changing a lot of resistors and you want to have some idea of how to do it neatly and what the differences are. I'll use calipers. I think I've got it set to inches right now because this is SAE, but I can convert it to millimeters if I want. I'll just measure the gap. So 9.94. I've got a 9.5 here that should work just fine. So this is a 27K. I'll go to the 9.5. Kind of center that. Give it a nice loose bend, just with finger pressure. Should drop right in. A little bit of a tight fit, which is good. Means when I do this, you see it's raised a little bit. It's got a little bit of strain relief built in. I like that. It's hard to do that by eye. You either get too much or too little. And let's see if it's the same for this one. Yeah. Doesn't have to be precise, but I try to get it as close as possible without redoing it. And I like to have the tolerance bands all going the same direction. It doesn't matter electronically what the orientation is of a resistor like this, but Leo always had the tolerance bands either down or to the right. So I try to do the same. Just got to get that lined up the same amount. I can finesse it a little bit as necessary. bent that one too soon. All right. So when this is together, there'll be no strain on any one of these connections. Now, there are some places in a power supply it's good to use a metal oxide or a wire wound, both in terms of heat tolerant, heat management, and the electronic properties of the material. And if these were, some 10 ohm or 220 ohm resistors with a lot of current because they're dropping so much, that would come into play, and I might use some metal oxides. For these 10K and 27K, there's not a lot of current through them, just the way Ohm's law works. So I don't have to worry about any of that. What I'm worried about is just the temperature and humidity stabilization, and these 2-watt Vichy metal films do a great job of that. All right, now on to the fun stuff. This amp originally had only four 16 microfarad, 475 volt rated filter caps. These are the old Mallory's with cardboard tubes. And that's kind of an unusual thing. The Vibrolux and the Deluxe Reverb both used 5 16 microfarad 475 volt caps, with the first two run in parallel. We'll talk about parallel and series and all that fun stuff in just a moment. But the the non-reverb Deluxe, the Deluxe without reverb, was considered to be more of a student model than the version with reverb for whatever reason. And it only had 4, so its first stage was just 16 microfarad versus the 32 of its reverb-equipped variant. And it's not just a budgetary thing. That increased filtering on the first node, the reservoir stage, does good things for the rest of the circuit. It gets more ripple off the amp without over-filtering. And so the Deluxe Reverb had 32. The non-reverb Deluxe had 16, which made the amp not quite as nice as its more expensive sibling. So I could easily put in a 16 microfarad 475 volt. But what I'm going to do, and this is with the owner's permission, because a future owner can always have it put back to 16 if they want, I'm going to use this 30 microfarad 500 volt FNT, which will give the same result pretty much as the two 16s in parallel that you'd find in the Deluxe Reverb. No one's going to hear a difference between 30 microfarad and 32 microfarad, but you'll hear a heck of a difference between 30 and 16. And I'm also using the 500 volt rated cap, just because even if we run this with a Variac, 114 volts supplying it, that first node has always been kind of right up on the edge. When you first power the amp on, there can be a surge. It drops down to typically 440 tops. So 475 is not so bad. I'm just going to bias some extra voltage with this 500 volt, and then we'll use the 475s for everything else. Now let's talk about series and parallel. So I've got two 16 microfarad caps here. In the Deluxe Reverb, they're running parallel with each other, which means that the positives are tied together and the negatives are tied together. So the capacitance adds up, and you get 32 microfarad total, but the voltage handling stays the same. You still have 475 volts max. If you run them in series, you double the voltage. So you could have 900 volts, 950 volts caps, 950 volts of voltage handling, but the capacitance would have. So you'd have an 8 microfarad 950 volt cap, or a 16 microfarad 475 volt cap, or a 32 microfarad 475. So that's why they ran it in parallel on the Deluxe Reverb to get more filtering. And that's also why on a lot of Deluxe Reverb reissues, I will use 22 microfarad 500 volt caps just to get that additional voltage handling, and you won't hear a difference between 22 and 16. On some amps, especially early 70s Fenders, the screen node can get pretty hot. It's like a late 70s ultralinear. You may find that you have 480 volts on the screen, and it's got a, that's right up against the 500 volt rating of a cap. Sometimes it'll even higher than that. So I'll sometimes will do a series trick on the screen node of some 70s Fenders, but that's beyond the scope of this. Anyway, I've shown this before. I like to just kind of eyeball it and get it centered with the value reading up. Find where to make my first bend. It's a pretty forgiving process. You have a little bit of wiggle room built into it. Try to get them all kind of nice and neat. Nice curve. That one I could do better. Just pre-bend them all, because once you add the silicone goop, you've got a shorter window, and if you make a mistake, you can fix it, but you're going to have goop at that point. Things get sticky. Things get messy. And it's not that kind of channel. Hopefully. I'm not too concerned that these aren't exactly centered. Once I go into the eyelets and I tuck them in, I can make some micro adjustments. Make sure it's all visually nice. They're little wiggles. One of the frustrating things about ordering capacitors is that they come in a bag, and the leads are always kind of bent around from just being twisted up to fit inside a bag. I suppose if I were buying from a factory, they'd come in reels, and maybe this wouldn't be an issue. Would not be an issue, but I'm unlikely to be ordering 10,000 of them myself. So getting them all straight and neat can take up a little more time than I like. But I hate seeing them being all janky. I try to make sure they're all on the same plane. All right, now, I've talked about this before, but it never hurts to talk about it again. Where did I put that stuff? Aha. Clear adhesive sealant, or silicone RTV. It's a non-reactive. This is made by Permatex. You can get this at Tube Depot. You can usually find this at AutoZone or O'Reilly's or, pardon me, your preferred car place. You want the non-reactive stuff because it won't dissolve the plastics on components and stuff, and it doesn't off-gas and hurt things adjacent to it. You can also find this sometimes at pet stores. It's sold as aquarium-safe silicone. Just a little bit. Doesn't take a lot. And when that sets up, when it cures, it will take the mass, it will be holding the mass of the cap body to the board, so there'll be less strain on the leads where they join the cap body. Let me go ahead and do that to all of these caps. And again, it does not take a lot. And the next time you need to work on this, 20 years from now, and this thing gets recapped, that old silicone will come right up with the slightest touch of a razor blade. Don't even have to really scrape it. It doesn't want to stick to the fiberboard permanently. Easy peasy. In comments, people also often ask, are you using hot glue? Can I use hot glue? What kind of hot glue should I use? Hot glue should pretty much never be used inside a guitar amplifier. First of all, it becomes brittle and does not stay where you want it to. Second of all, it melts with high temperatures, hence the name, hot glue. It can get very, very warm inside an amplifier. Very, very warm. And the last thing you want in that situation is for anything that you're trusting to be glued to no longer be glued. As I mentioned in the previous video, it's important that you wipe up any excess before you put the cap on. Otherwise, this thing will cure hard as a rock, and you'll have to go spend another $9 to get another tube. If you clean up that excess before you put the cap on, it can last 6 months. Probably lasts most people longer. Here in the shop, I get about 6 months out of that if I remember to clean it up. Then I trim the excess leads off leaving just a little bit, and see that they are going underneath the board so that when this board is screwed down against the backing board, all these leads will be sandwiched in place, which will make a nice mechanical connection before solder is even applied. I haven't even soldered it yet, but everything's staying in place. And with just enough mechanical force that if I were to pass voltage through this circuit would actually be operating already. It wouldn't have negatives. You know, it would have the potential to operate, wouldn't have the connections to ground. But if you were to apply voltage here and negatives here, you would have the expected drop across each resistor. This would work. Let me stop talking about things that I'm not set up to demonstrate, but if you know, you know. And we'll fish the original wires through the respective holes in the sequence according to length. And we will not forget about the little black one, red one here that likes to poke down. I will not forget about this little yellow one that likes to poke down. It's really easy to just compress those and push them down into the chassis by mistake. So let's reinstall those two screws first. And I don't tighten them all the way until I get both of them seated, because if I tighten this one down, it's harder to rotate this one. You can end up stripping a screw. I want the board to move according to where the screw needs to be. There we go. That feels like if I were to keep turning it, the chassis would strip and that screw would just start to free spin. These are just machine metal screws, and there are only so many times that you can turn them, remove them and reinstall them before the metal of the chassis will give out. If that happens, it's not the end of the world. You can replace them either with the next size up sheet metal screw, or you can go to machine screws and nuts. But that's a little bit difficult to do on the other side of these boards because of the boards on the other side that would run into. So try very hard not to strip them. But if this number 8 were to strip out, you can replace it with a number 10 sheet metal most of the time. Just get some fresh metal in the game. But it is not the best design ever. Sheet metal screws. For things that are rarely unscrewed and retightened, they're fine, but that is not the case. Well, typically, this is done every 15 to 20 years, so not too bad. But it's one of the few things where I think Leo could have gotten it a little bit better from a service perspective. But, if 60 years, so say this should have been the third time it was ever recapped. That screw should have been out 3 times in its life. That's not too bad a track record. Let's do the middle 2 grounds. Now the outer 2, these were the ones that were so tight before. I'm going to get this to stay in place before I solder it. Let's see, where's my teeny tiny flathead? It's not the teeny tiny one, but maybe this will work. Now, I put a bend in there. I want it to hook underneath that eyelet. I don't want it to just be tucked in. I want it to stay in place before I solder it. Let's see. Confirm that hook with the dental pick. It's pretty good. I think I can get it better. It's a game of margins. When something some things don't make a difference, and you might do them just because they're best practice or good habits to have, and some things do make a difference, and it's worth taking the time just to say, you know what, that is one of the most important grounds in the entire amp, that reservoir cap ground. I'm going to make sure that doesn't come loose. No one will ever regret doing the ground too properly, or just taking that extra minute on a crucial connection. That lack of slack is actually our friend on this. It's making it want to stay in place with that little hook I added to it. Now, I know you're not seeing everything I'm describing with the little hooks and stuff. Maybe you're seeing enough. But the premise of the real time, someday I'll probably have like, if the channel continues and people are still interested, I'll probably have like 3 cameras set up. And after the fact, I can switch back and forth and you can have all these different angles. It just takes, all you need is cash. And remember, I'm also my editor. So a lot of big channels, not everyone knows this. A lot of the larger channels, the guy whose channel it is, who you see on there, does the fun part. There's work. You write your scripts, you prep, you plan, you have meetings, you assemble your team, but then you do the filming, and then you hand it off to your editor, and 3 weeks later, it's ready, and you add it to your release schedule. Meanwhile, you've been doing other things for those 3 weeks while the editor spent 3 days on it, whatever. If you're a one-man show, it has a lot of benefits. I much prefer being the only guy doing this for a lot of reasons, but when you're also the editor, say this is an hour-long video or hour plus with just one camera, then you have 3 times as much footage, and you're going back and forth. You have to watch that video multiple times in the process of editing it. You can have days involved. And it'd be great if you're getting paid to edit videos. I'd love to have if I could turn this into a job just doing really cool video editing for people, that'd be fun. I actually have come to really like the process. And there are a lot of things that I know how to do that I don't do in the video editing, both because of time constraints. It's not the focus of the channel, and it would just be distracting. I don't think you guys care about floating text coming behind the components on a board, between the resistors and the board. All of a sudden, a floating text pops up and really cool motion blur transitions with the Sahara Desert in the background and stuff. I also have had to stifle the urge to say, well, yeah, sure, this is what the amplifier chassis looks like in real life. But what would it look like in Blade Runner? This is the only one I've not gotten to hook yet. But I don't want to tug on it too much because the old cloth can be a little bit fragile. Start it. Almost. Aha! Ha 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 ha. All right. Waiting for the iron to heat back up. Check my pretty domes. If this is the first one of these videos of mine you've seen, the domes are a bit of nonsense as far as soldering goes. It's not the proper way to solder. The proper solder is beneath that. It's the fillet. Doing the domes is beyond mil spec and just wastes a little bit of solder. It doesn't hurt anything, but it just cosmetically make it look more like the domes that Fender's factory did, because they did all the solder upside down, so all the solder would form these pretty domes when you flip the board back over. So if you're watching this channel for the first time, you think this dude using way too much solder. The dude knows that. The dude is making a conscious choice, but the dude is very sure of the correct joints hiding beneath those cosmetic domes. I should mention, as I'm cleaning up the excess flux with this bit of ISO, you don't want to spill any ISO on the board at this point, because that silicone is not set up, and it will just make you have an oozy, gummy mess everywhere if I were to get wet, the silicone exposed to ISO. Let me just confirm that all the hardware for the transformers is tight on the side. That one's not, and that one's free spinning, as a matter of fact. I know these are tight, but this one very much is not. There's a little bit of wax here too. Let me get that wax up. Let me remove this and see what our options are. Someone's been in here. There should not be all that wax between the transformer mounting flange and the chassis. That needs to have good metal-to-metal contact for ground. And I'm pretty sure I'm going to have to either use a larger sheet metal screw here, as discussed, or get in there with a machine screw. I'll probably do a machine screw, but first let me get this wax off. It's not just wax, it's like a gummy, yucky wax. That screw was free spinning. Let me put the other screw back on the other side. Make sure it goes all the way tight. All right, that one's tight. This one was free spinning, and I can see what I suspected I would see. The threads are thinner right here. So maybe that the screw is stripped, but the chassis is okay. Let's find out if that's right. No, it's the chassis, because the strippy looky area is the first part of the screw. So I'll move that to the side. We'll slightly loosen the other end. Retighten the other end just so this is held on mechanically. And make sure we have clearance on the other side. Yeah, let's let you see it. Right there is where that screw goes through. Well, real-time proof. Right there is where that screw goes through, so I can do a machine screw there with a nut and be better connection than ever in stock form. I can use a number 6. So let's see here. Where is the bit I want? All right, cool. That's a 125, 1/8 inch. Let me find my, I think it's 9/64 is the right size for a number 6. Oh, hell, before I do that, let me just see if a number 6 screw fits in there, whether I need to drill it out. Usually I need to drill it out a little bit. All right, number 6 is going to fit in there without drilling it out. It'll just go. This is number 6, but this is not the one I'll use. Let me go to my stash and get the right hardware for what we're going to do. Now that I know I don't need to drill it. All right, I've got a number 6 stainless screw. I'm going to put a number 6 stainless washer on it. Put it through here. That washer just makes the screw a little bit area wider where it contacts the flange. It's less likely to bend the flange in the middle. Pop that down. I'll start this. This is a nylock nut. I'll start it by hand and then tighten it with the proper tools. All right, I've got a 5/16 inch nut secured from the bottom, so I can use the screwdriver from the top. I can really clamp the hell out of it now. If I use that much torque on a sheet metal screw, it would just start to spin, or something would shear off. All right, that output transformer from 1963 is now rock solid again. I know that the choke's fine, doesn't have a reverb driver, and I know that from the other side that the power transformer is good. Let's flip this around and get started on the other stuff. Now, I've been recording a lot, and I only have so much. I need to get a larger SSD card. I think this is only 64 gig. I'm going to stop here for a minute, and I'm going to transfer these files to the computer, so I don't run out of memory on the recording card. Some pro cameras have more than one card. Mine only takes one, and later I'll get a larger one. But for right now, I'm going to pause and transfer these files over, and then we'll resume. If this thing looks like it's really long at any one point, I reserve the right to edit in a hey, I think I'll do this in 2 parts after all kind of thing. But for right now, I'm still planning on this being one large, very long, very tedious video, but real-time pause now.